this lesson, we're going to start our factoring. So we're going to have 3 days because we have lots of different types of factoring. And you have seen all of these methods before in Algebra 2. But factoring, as you might remember, is basically undoing a FOIL. The undoing of FOIL. Or that distributive property. So the difference of two squares is what we're going to start with. So remember that we need to know our perfect squares. So 1, 4, 9, 16, 25, 36, 49, or x squared, x to the fourth, anything with an even. We can do the square root of it. So for our first one, so we have difference of two squares would be a plus b and a minus b, because we're basically taking the square root. So take the square root and take the square root. So let's take a look at this one. And we have one with a plus and one with a minus, right? Because they're canceling out that middle term when we have a plus and a minus. So we're going to have a plus and a minus. We're going to do the square root. And so it's x and x. And the square root of 121 is 11. So it's x plus 11 and x minus 11. So this one down here, square root of x squared is x. We have our plus, we have our minus, and then we're going to take the square root, and that can be the square root of the top and the square root of the bottom, which is the same thing as just one square root symbol over the whole fraction. But square root of 25 is 5, and square root of 4 is 2. So 5 halves, and then 5 halves. Let's go ahead and add one more in here that's not already in here. Let's do a 9x squared minus 25y squared. So we're going to have our plus, we're going to have our minus. The square root of 9 is 3. The square root of x squared is x, so 3x. Square root of 25 is 5. Square root of y squared is y, so 5y. So there's our difference of two squares. Let's take a look at greatest common factor. Now that is similar to dividing out a common factor, but the factor does not go away. So let's see, we want to look for what they have in common and factor it out. So it is similar to dividing out a common factor, but it goes in front. So, but the factor does not go away. All right, so let's take a look at this first one. What can we take out of 4 and 12? We can take a 4 out, right? We can divide this by 4. There's no variable that they have in common, so just a 4. So we put the 4 in front, and then what's left when we divide that out? X, and then plus 3. On this next one, we look and see what do they have in common. So it looks like they both have that x minus 2 in common. So we're going to put these together, and then they both have that x minus 2 in common. Or we can put that in front if that makes more sense. We're basically taking out that x minus 2 from both. So pulling it out, putting it in here, and then what's left is an x plus 3. For dividing out that x minus 2, it's going to take it there, and here it is in front, just like we put our 4 in front, and then we're left with an x plus 3. However you want to kind of think of it. All right, so let's take a look now. When the leading coefficient is 1, we look for the two numbers that multiply to get that last term, but add to get that middle term. So we want to multiply to get 12, but add to get negative 8. So what are the factors of 12? Well, 4 and 3, but that's not going to get me 8. So maybe 2 and 6 add to get 8. And if they're both negative, it multiplies to get the positive, and then it adds to get that negative 8. So you can kind of write out your factors of 12, 1 and 12, 2 and 6, and then kind of figure that out. So we're going to put those in our set of parentheses. So x squared, what gives me x squared? X and x. And then what gives me 12? Well, the two numbers I found that are going to add to get that negative 8 are negative 2 and negative 6. Down here, let's take a look. Oh, perfect squares. So do your plus, do your minus. Here, what are the factors of 16? That are going to add to get 10. So go ahead, let's build this one out. 5x and 5x, 9 and 9. Again, one is a plus and one is a minus. Done with that one. 16, I know 8 and 2. Those add to get 10. So x and x to get x squared plus 8 and plus 2. Because it was a positive 10 and a positive 16. All right, go ahead and try this one. Think about what are the factors of negative 48 that would add up to get 8. Watch your signs. So 48, here's kind of some factors to help you. 1 and 48, 2 and 24, 3 and 16, 4 and 12. And we need one of them to be 8, or one of them to be a negative so that we can get 8. So it's probably going to be, so which one of those adds up to get 8? Yep, negative 4 and 12. And you can just do kind of that way. You don't have to do that x. So x and negative 4 and positive 12. What about negative 56? What adds to get multiplies to get negative 56 and adds to get 1? So 1 and 56, 2 and 28, 7 and 8. Oh, 7 and 8. If I make the 7 negative and the 8 positive, that would give me negative 56 when it multiplies, and it would add to get a positive 1. So x minus 7 and x plus 8. All right, so down here, let's take a look. We have still very, very similar to our other problems. We're still going to look at negative 27 and how it's going to add to get 6. So 1 and 27, 3 and 9, that could get 6 if I made the 3 negative. And yep, negative 27, that would multiply. So now I'm going to do x and x just like I had before. And then I'm going to do my negative 3 and plus 9. And then they have y's. How are we getting y squared? A y and a y. So that's how we're getting the xy, because we're taking, if we kind of FOIL, we get x squared. Then we get a 9xy. And then here we'll get a negative 3xy. And then here we'll get that negative 27y squared. All right, so go ahead and do number 6, pause, and then push play and check when you're ready. So to add up, to get 3, we should use 6 and negative 3. All right, so on this next one, number 7, notice that this has a number in front here. So we always want to look to see if we can take out the GCF. So don't forget to look for a GCF. To help simplify. So we can take that 3 out. And then we'll look for factors of 6 that add to get 4. So 2, 1 and 6, 2 and 3, and 6 and 1, and this is a negative 6, so even if I make one of those, that's 5, or negative 5, and that would be 1 or negative 1. So we cannot factor. we can just take out a GCF. That's all we can do. We can't factor it further. All right, so let's take out a GCF on this one because I see a common factor. So do not forget to look for that GCF initially. And we can take out a 3, so it's 3 and then 9x squared minus 1. Hey, that looks like perfect squares. So we can do a 3x plus 1 and a 3x minus 1. And then don't forget that GCF in front.